We are going to discuss subnetting and summarization scenarios in these visuals. So let's start discussing subnetting and summarization scenarios. Well, this is the first scenario we are going to discuss. Here you can see this is the network. We have to create 1, 2, 3, 4, 5, 6 subnetworks on these networks. So what we are going to do with all this? Now just remember the rules, the block size, which the process which we use to subnetting. Well, I have just disappeared that rules and block size numbers which we had on top right while discussing IP addressing visuals. Now we must have these values in our mind, so we are going to compute all these subnetworks by using those values and interpreting those values in our mind. So first we have to look. Now we have looked that we are required 6 subnetworks on this network. Well, now second thing which we are going to confirm that which octet is using for all this. This is the, as you can see, 24 describing that this is the class C subnet mask. So we are going to play from bits 25 to 32. So this is also cleared. Now let's start subnetting this scenario. For this network, required users are 99. So we cannot create a subnetwork that exactly gives 99 users valid hosts. So we are going to have near about subnetwork for this required 99 users network. Well, what we are going to do is we have to apply the rules regulation. At first, just remember that we are going to apply from left to right. By enabling first bit, we got 25 bits, so it gives us the subnet mask of 255, 255, 255, 128. So that subnet mask gives us the block size of 128. So 128 block size means we are getting 126 users. For this network, the most suitable subnetwork is 128. Subnet mask is 128, which gives us 126 users. So we are going to apply that subnet mask here. I'm going to show you a bit later. Let's discuss regarding this one. So the required users for this network is 47. So what we are going to do again now, the most suitable block size for this network is after 128, the next block size is 64. So we are going to apply subnet mask for this network is 255, 255, 255 and 192. We got 192 subnet mask by enabling 2 bits, and just remember that 192 subnet mask gives us the block size of 64. So you can just go to the next suitable network according to now 29. So I can see clearly that most suitable subnet mask for this network is dot after 192 is 224. By applying 3 bits 128, 192, 224, we got the subnet mask of 255, 255, 255 and 224. For this subnet mask we are getting the block size of 32. So 32 minus 2 gives us 30 valid hosts. So it will meet requirement for this network actually. Now let's move another. It is 11. For this network our requirement is 11 hosts. So what we are going to do with this network is just look at the rules. Now 128, 192, 224 and 240. Yes, 240 gives us the subnet mask of 255. 240 gives us the block size of 16. So 16 minus 2, 14. So now 240 subnet mask will be applied here best. Let's move further. It is 5. Now what is the best block size apply here? Actually suit here, it is the 128, 192, 224, 240 and 248. So 248 subnetwork gives the block size of 8. 8 minus 2, 6. I think it is the best suitable subnet for this network. After that 2. So I think that the subnet mask of 255, 255, 255, 252 gives us exactly 2 hosts. So 252 subnet mask, we apply 128, 192, 224, 240, 248, 6 bits. By applying 6 bits we got subnet mask of 252, and 252 gives the block size of 4. 4 minus 2. Now 4 minus 2 gives exactly 2 valid hosts. Now let's see here, same exactly. Now here we are applying 128 subnet mask from hosts 192.168.1.1 to 192.168.1.126. These are the valid 126 hosts, and 192.168.1.127 is our broadcast for this network, while 192.168.1.128, this is the next network here. Now this network's valid hosts are from 192.168.1.128 and .190. Actually yes, 190 here. So 192.168.1.191, this is our broadcast address for this range. Let's move further. Here it is. This is the next network. It gives the subnet mask of 255, 255, 255, 224. The valid host range for this network is 192.168.1.192. Valid host address ranges from 192.168.1.193, from 193 to 192.168.1.222, and broadcast address for this range is 192.168.1.223, and the next network is 192.168.1.224. For this network, valid addresses are from 192.168.1.224 to 238, and broadcast address for this network is 192.168.1.239. Now let's move towards next network. For this network, valid addresses are from 192.168.40.241 to 192.168.240.250. Actually yes, broadcast address, the broadcast address for this range is 192.168.240.251. So let's move. The last network for this scenario is here. Now this is the network 192.168.40.252. For this network, valid addresses are from 192.168.240.253 is the first, and .254 is the second and last. Broadcast address is 255. So let's move towards other scenarios. Now this is the list of IP addresses. We have to determine valid IP addresses from this list. Well, this list contains network addresses. They give the look of IP addresses, but those network addresses cannot be used as valid IP addresses. And this list also contains some broadcast addresses. So this is the real exam. Now this is the first IP address. Now just tell me that, is this the IP valid IP address or network address or broadcast address, in case it is a valid or invalid IP address. Now we can see that the /30 providing us the subnetwork is just apply those bits. Now 25, 128, 25 bits provide 128. After that 26 provide 192, 27 provide 224, 28 provides 240, and where I am now, let's start again. 128 provides 25 bits. 25 bits provide 128 subnet mask. 26 192, 27 224, 28 240. After that 29 248 and 30 provides us 252 subnet mask. Now just we have to analyze. Now it is 252 subnet mask gives the block size of 4, so just apply the 4, and it is 4th octet, so the difference of 4 would be applied at 4 octet till we reach 132. Let's start now. 0 4 8 12 16 20 24 28 32. After that 36 40 44 48 52 56 60 68 72 80 88 88 92 100 100, and it is the network address. It is actually invalid IP address. It cannot be used for host. Let's move towards another address. Here it is. So this is the example of class B subnetting process, if you remember. Well, 22. I know while subnetting class B, we were playing with bits from 17 to 24, 23 actually. 24 was the default, is the default subnet for class C. Now, is this the valid or invalid IP address? So we have to determine what is the exact subnet mask for this network. Is now 22 bits gives us 17 128, 18 192, 19 224, 20 240, 21 248, and 22 252, again 252. So 252 gives the block size of 4. So just apply the difference of 4 on 3rd octet. Just remember the octet position. We are playing with class B bits, class B subnetting, and here the place is 3rd octet. So from 0 to 4. So this is the valid IP address, because this the valid range for the for valid IP addresses ranges for this network is from 10.0.0.1 to 10.0.3.254 and 10.0.3.255. This is the broadcast address for this network. So I'm playing with these bits without using any help. I just followed the rules and regulations which were created for IP addressing, which we have discussed previously, and by playing with those rules and regulations, by applying those rules and regulations, I am exactly on my way, and I am feeling very confident to get a valid or invalid IP address to compute actually. Now let's move towards third one. Here it is, 12.12.1.255. Now we have to determine that is it a valid or invalid IP address. Now we can see it is /2323. It means that it still lie in class B subnetting from bits 17 to 23. So it is of it is the class B subnetting example. Well, now /23 provides the subnet mask of 255.254.0. Yes, it is. Just remember that applying 7 bits from left to right gives 254 and block size of 1. So it is from 12.12.1.255 5 dot 12 dot 12 dot 0 dot 1 to 12 dot 12 dot 0 dot 255. Let's compute it again now. Well, 128, 192, 224, 240, 248, 252. It's 254 subnet mask, 255, 255.254.0, and the block size is 2. Now by the difference of 2 starting from 0, 12.12.0.1, this is the first valid IP address, and from this IP address to 12.12.1.254, well, these are the valid addresses. Now this is not the valid IP address, this is the broadcast address for this network. Now till yet we have computed 3 top IP addresses, and let's see what is the real result. Now I told you that it is the network address, and this is the valid IP address. We have also computed this one, and this is also invalid IP address. This is the broadcast address. Now let's get back and configure and summarize and compute our remaining IP addresses. This is the next one. For this IP address, first look what is the prefix length. It is 28, so it means it belongs to class C subnetting from from bits 25 to 32. So these bits belongs to class C. Now from 25 to 28, these are 4 bits. Now 128, 192, 224, 240. With 240 we are getting the block size of 16. Just apply the difference of 16 till we get in 140s. Now 0, 16, 32, 32 and 16 and 16, 64, 64 and 64, 128 and 128 and 16. It is 128 and 16, what, 128 to 130 and 144. Now this is the invalid IP address because 143 is the broadcast address. The valid IP addresses for this range is from 129 to 142, and broadcast address is .143, and the next network address is 1.144. Let's see the right answer. And yes, it is invalid IP address. It is the broadcast address. So let's move towards the next example. Actually, yes, it is. Here it is. Now here it is. Well, this is the class A subnetting example. 10.1.255.255.255. Well, it is right wrongly. These are 5 octets. Well, class A IP version 4 address consists of 4 octets, so these are 5 octets. Now let me see what is the right IP address for this. It should be 10.1.255.255. let me see. Here it is. Yes, it is. Here it is a valid IP address, but it is 10.1.255.255. Let's configure here. Here it is mentioned clearly. There was wrong. Do not consider that one. It consists of 4 octets. Well, such mistakes. Okay, now 10.1.255.255. we have to analyze whether it is a valid IP address, but we will configure using our rules and regulations. So by seeing its length, prefix length is 14, we can analyze that this IP address belongs to class A subnetting. So for this we are using bits from 9 to 15 for class A subnetting. Actually we can use more, but we are assuming these bits here. Let's see how many bits we are applying here. From 9 to 14. Now 9 gives 128, 10 gives 192, 11 gives 224, 12 gives 240, 13 gives 248, 14 gives 252. With 252 subnet masks, the block size is 4. Now by applying the difference of 4 on the second octet, now it is valid IP address, because from 10.0.0.1 to 10.3.255.254, yes, these are the valid IP addresses, and 10.3.255.255, this will be the broadcast address. Yes, it is. And the next network address would be 10.4.0.0. Yes, because with the difference of 4. Now these are very complicated scenarios, and we are doing without using any help, just memorizing those rules and regulations. Here it is a invalid IP address, and it is a broadcast address. So let's analyze why it is invalid IP address. Now again, the example is of 14. So we are getting the subnet mask of 9 128, 10 bits gives 192, 11 bits give 224, 12, 240, 13, 248. Yes, it is 252, and the block size of 4. So by applying the difference of 4, 4, 4, 4, 4, 4, 4, 4, yes, 128. I can get into 128 because of much practice. Okay, and 128 to, okay, now this is the broadcast address of the network 10.128.0.0. Valid addresses for this network is from 10.128.0.1 to 10.131.255.254, and this is the broadcast address. Exactly right. Alhamdulillah, I can do this. Thanks to Allah subhanahu wa ta'ala. Well, let's move another. It is valid IP address. How it is, we have to find it. So with the different, okay, now it is /30/30 /30 is telling me that this IP address belongs to class C subnetting. Now, well, 30 provides the broadcast the subnet mask of 252. Yes, it is 252. The block size is of 4. Now apply the block size 4, 4, 4 till we are reaching 128, 444, 192 and 224. Yes, this is the second valid IP address for network 192.168.1.224. the first one is .225. the broadcast address for this network is 192.168.1.227. the next network is 192.168.1.228. let's move further. Here it is valid IP address. How it is, let's analyze. 21 is telling me that this has been happened with class B, and from 17 bits gives 128, 18 gives 192, 19 gives 224, 20 gives 240, and 21 gives 248, and 248 gives the block size of 8. 248, yes, 8, it is 8. Now with the difference of 8 applying on third octet, just remember the octet position, it is very important. Now third octet from 0, yes, now it is valid IP address. Exactly. Now valid IP address range for this network is from 172.16.0.1 to 172.16.7.254. broadcast address for this network is 172.16.7.255. let's move further. Here it is valid IP address. Why and how, let's analyze. It is 17 bits. Now by enabling first bit, we are getting the subnet mask of it. It belongs to class B, and by applying first bit we are getting 128. so by using 128, subnet mask provides the block size of 128. again 128, remember the octet position, it is third. So from 172.16.1 .0.1 to 172.16.120, 177.254. These are the valid IP addresses for this network, and broadcast address is 172.16.127.255. Next network following this series is 172.16.128.0. Let's move further. So here it is. Now this is the valid IP address. Yes, it is exactly. By seeing 24, it is a default subnet mask, and valid IP address ranges from 17.0.0.1 to 17.0.0.254, and .255 is broadcast address. Let's move further. It is invalid IP address. Broadcast address, how it is, let's analyze. /28 telling me that it belongs to class C subnetting. Okay, so it applied 4 bits from 25 to 28. Now 128, 192, 224, 240. Okay, 240 gives belongs to 16. Apply 16 on 4th octet. Okay, 16. Okay, it is 224. Apply 224 to 25 to 238. Okay, it is broadcast address exactly, because the network we're getting is 125.0.1.224, and valid IP because 16 minus 2, and valid IP address ranges from 125.0.1 to .1.225 to 238. And it is the broadcast address exactly right. Now it is valid IP address. How it is valid IP address? Just see 192.168.168.190. Okay, there are 4 doctors. I thought it was 5. Okay, now 26. So it applied 2 bits on class C subnetting 128, 192, but 192 subnet mask is giving the block size of 64. Apply 64 here. 64, 120, 128, and 64. What we got? 128 and 64. 128 and 64. 230, 30, 60. Okay, it is valid IP address because the block I got the network 192.168.168.128. This network provides valid IP addresses from 192.168.168.129 to 190. This is the last valid IP address for this network. The broadcast address for this network is 192.168.168.191, and the next network is 192. Let's move further. Now for this example, it is valid IP address. How it is, let's analyze now. Prefix length is telling me that it belongs to class C subnetting /27. Well, from 25 to 27 it is 3 bits. 128, 192, 224. 224 gives the block size of 32. So apply 32 till we get 160. 128. So 128 and 128 and 32. How it is valid IP address? Now let's start. 32, 64, 64 and 32, 96, 96 and 32, 4, yes, 128. So the difference of 120, 192, 224, yes, we're getting the block size of 32, and with the block size of 32, valid IP addresses we are getting for class C is 30. Just remember the formula, block size minus 230. So this is not the valid IP address. I mentioned wrong. Sorry for the mistakes. So it's okay. The mistakes really help to get the perfection. So 128, 10.0.0.128. This is the network. Valid IP addresses are from 129 to 30, 159, I think. 129, 139, 149. I am sorry, confused, very confused with this example. 130. Let me compute it. Yes, it belongs to 128, and now 128 network. We got 128 network from 129 to 159. Yes, 10.0.0.128. This is the network, and valid IP addresses for this network is 10.0.0.129 to .159. Dot 129 to .159. No, 129 to .158. Yes, these are 30 valid IP addresses, and 10.0.0.159. This is the broadcast address, and this 10.0.0.160, it is next network. Yes, it is the network address, it is not the valid IP address, and sorry for the mistake. Let's move further. So next example, invalid IP address broadcast address, let me see, 172.16.16.127. Okay, let's analyze. /27 is telling me that it belongs to class C subnetting, and 125, 26, 127. It is 3 bits, 192, sorry, 128, 192, 224, with the difference of 32. So yes, 96, and it is broadcast address exactly. Now 172.16.16.96 is the network, and valid addresses for this network is 172.16.16.97 to .126, and .127 is the broadcast address. It is exactly right, and it is actually right. And the next network is 172.16.16.128. So let's move further. Two examples left, three actually, after yes, three actually in total. 10.128.255.255/9. Okay, it belongs to class A, exactly same, and yes, it is valid IP address. Now just look at the octet position. It is second octet, and by applying one bit we are getting 128 subnet, and it is exactly valid IP address, because the valid IP addresses for this range is from 10.128.0.1 to 10.255.255.254. Yes, I think it is right. Exactly, I think. And 10.120 10.255.255.255, I think it is the broadcast address. I think it is, yes. What remains after this? Let's move further. It is telling that it is valid IP address. Let's analyze. 10 is telling that it belongs to class A subnet example. So 4 bits are applied for class A subnetting from 7 to 10. Yes, 128, 192, 224, 240. So with the difference of 16, let me compute again. 128, 192, 224, and 240. So 9, no, it is 2 bits are used for first net for class A subnetting. I'm sorry, I thought it used 4, sorry. And let's compute it again. Well, it is /10, so from 9 to 10 it is 2, 128 and 192. So the subnet mask is 255.192.0.0, and block size is of 64. So it is exactly valid IP address, because you can see 13.0.0.0, it is the network, and valid addresses are from 13.0.0.1 to 13.63.255.254, and 13.63.255.255, it is the subnet mask. Now this is the valid IP address, because 13.62.255.255, it belongs It is in the range of 13.0.0.0 network by using /10 length. Now loopback address, well, it is exactly the loopback address 127.16.16.16. Yes, it is, because 127.0.0.1 to 127.255. So this whole range considered as loopback addresses. So we have gone through these very useful examples, and just revisit again till you get comfortable with subnetting. I think we are much more comfortable now. Let's get on some summarization examples. For summarization, just recall those steps. Okay, it is contiguous network. Yes, it is. Just look at the octet octet for we are going to summarize. It is 4th octet. It is okay. Now just look at the difference from 0 to 40. What do you think? What is the best summarized network? I think 10.0.0.0/24, because 0 to 240 it is covering almost a whole range from 0 to 240, so it will use a default subnet mask easily. 10.0.0.0 10.0.0.0/24, and well, it is, let's see, yes, this one is our summarized network for this range. Okay, let's move further. Let's look at another example. Recall your steps. So it is 3rd octet, and well, the difference is of 3. So what is the suitable block size? 4. So which subnet provides the block size of 4? 250T provides 252 actually. 128, 192, 224, 240, 248 and 252. Yes, by applying 6 bits. So 10.0.0.0/22, and yes, this is the summarized network for this contiguous networks, because this network ranges from 10.0.0.1 to 10.0.3.254 and 10.0.3.255 is broadcast, so covering all our required range. This is the range. Let's move another example. Now for this example, look at where the changing is taking place. It is the 3rd octet again, and the loss value is 129 and the increasing one is 143. So what is the difference? I think 32 will apply, the block size of 32 will be applied best here. So it is 3rd octet, so go to class B, and how many bits provides the subnet where we found the block size of 32? Well, 128, 192 and 224, so 3 bits. Just apply 3 bits. It is 19, I think. It is 19, I think. And for 19, just look at the lowest IP lost network. It is 172.16.128.0 129.0. So what we got here is 172.16.128.0/19. So this network will help to summarize this network. How it is 20? Now we have to compute it again. This is mistake here. The right summarized network is 172.16.128.0/19, because /19 provides the subnet mask of 255.254.0 and block size of 32. So valid IP addresses ranges for this network which we computed is 172.16.128.1 to 159.254 and .255 is broadcast address, and 172.16.160.0 it is the next network. So this is wrong, and I think mistakes really help us to get the perfection. Let's move further. Here it is. Now for this network, what we are getting, just see the position where the changing is taking place. Actually, the changing is taking place on third octet also, but on second octet also. So we have to summarize the network using the second octet. So look at the changing here is taking place. It is second octet from 16 to 29. So I think it is 16 to 29, 30. Yes, it is 16. The difference of 16 will be applied here more perfectly. So, and I think it would be the second and third. Okay, let's analyze. Well, the difference of 16, just look which subnet mask provides us the block size of 16. So 128, 192, 224, 240, yes, 4 bits. By applying 4 bits we are getting the subnet mask of 255.240.0.0 and network 172.16.0.0. Yes, this is the network we are getting for summarizing these networks, because 172.16.0.0 by using slash 1 2 3 4 8, and I think it will be 12 bits, 128, 192, 224, 250. Yes, it is 12 bits. By using 12 bits, the address range would be 172.16.0.1 to 172.31.255.254. Yes, these are the valid IP addresses, and the subnet mask is and the broadcast address would be 172.31.255.255, and the next network would be 172.32.0.0. Yes, I think to me it is, and I was right. I am right, and the answer is also right. Let's move another example. See the changing where taking place. It is third octet from 149 to 173. I think the difference is of 32. Don't you think? Yes, it is. So what is the right choice for summarizing these networks? So from 149 to 173, I think hmm, I think not 32. Here let's start 120. Let's start what best block size apply here. So here applies the block size of 64, because 120 from 128 to 192. Yes, this will cover these range. So let's see what the subnet mask gives us the block size of 64, 128, 192. So by using 2, so it is the third octet. So by using 2 bits we are getting the subnet mask of 255, 255, 192 and dot 0. And for this the block size is 64. Just apply the difference here, starting from 0, 64, 128. So yes, 128. Here it is from 128 to, yes, the network would be, summarized network would be 192.11.128.0 slash 18. I think it is 18. Let's check the answer. I think it is 18. Yes, it is 18. So valid IP addresses are from 192.11.128.12, 192.11.191.254. So these ranges covering all these networks you can see, and the broadcast address is 192.11.191.255. The next network would be 1.192.0. So we are almost done. We have With this I am concluding this visuals. We have covered a lot of examples of subnetting summarization. If you feel any problem, just replay this visual and be prepared for upcoming visuals. Thank you.